So we'll start today with part 2 of lesson 3, and this is calculating pH and pOH when we have word problems. Always, what do you have to keep in mind when we are calculating pH and pOH? You'll have to remember that flow chart that we discussed even on the previous lesson. So if we have the hydronium ion, concentration of hydronium ion, and we want to calculate pH, then what we do is we go negative log of the concentration of hydronium. And if we know what is the pH and we want to calculate the concentration of hydronium, so when we move on this direction, then what we do is we go negative, concentration is equal to 10 to the power of negative pH. Negative pH. When we know the pH and we want to move to pOH, pOH being here, and then we use the fact that the sum of the two is equal to 14, so pOH will be 14 minus pH, or opposite, when we know the pOH and we want to calculate what is pH, so then we go pH is equal to 14 minus pOH. And then the concentration of hydroxide, knowing pOH, will be calculated as 10 to the power of negative pOH. And when we know the concentration of pOH and we want to calculate the concentration of hydroxide and we want to calculate the pOH, then we go negative log of concentration of hydroxide. But on the cases when we have word problems, what do we have to do is we have to find the concentration of the ions on some cases. Okay, so now what do we have is what is the pH of a solution with 1.2 grams of hydrochloric acid gas that was dissolved in 890 milliliters of water. Okay, so now what is happening with the hydrochloric acid in water is ionized. We went over this concept on lesson 1 of this unit. So it is an acid and will be ionized. So when we have a hydrochloric acid in aqueous solution, what is happening is we will have hydrogen in aqueous solution and chloride in aqueous solution. So this is ionization. It's ionized. Okay, so now what is given here is that we have 1.2 grams of hydrochloric acid, and we want to calculate the concentration of hydrogen plus. Okay. Why hydrogen plus? Because hydrogen plus is in contact with a molecule of water to provide hydronium. Okay, so when we write this equation, since it is in aqueous solution, means that we will have water there. So then we will have hydronium in aqueous solution and hydrochlorine. Okay, because this is ionized. Okay, so now we'll start with the calculating the concentration of hydronium. So 1.2 grams of hydrochloric acid. In order to find the molar number of moles that this hydrochloric acid has, we have to use the molar mass. The molar mass of hydrochloric acid, having 1 hydrogen and 1 chlorine, is 36.46 grams. And we have 1 mole here. So grams and grams is cancelled out. And then we will have the molar ratio between the hydrochloric acid and the hydrogen or proton is 1 mole of H plus 1 mole of hydrochloric acid. So moles of hydrochloric acid is cancelled out. And now what we have is the number of moles of hydrochloric acid, but we want the concentration. Now this concentration is moles per liters. So then we will go, this amount is dissolved into 0.890 liters. Okay, so now the concentration or the formula is moles per liters. And then using the calculator, we will enter 1.2 times 1 times 1 times 1, divide the whole thing by 36.46 times 1 times 0.890, close brackets, and you will have a concentration of, so you will have a concentration of 3.7 times 10 to the power of 2 concentration of hydronium. Because concentration of hydrogen or concentration of hydronium is the same thing. They are equal to each other. And now using the flow chart, the pH will be negative log of concentration of hydronium, and it is equal to 1.43. Okay. Next example is saying that what is the pOH now of a solution in which 14.2 grams of phosphorus acid is dissolved in 1.50 liters of water. What I will do is I will open a new page and then do all those questions in a very large space so that you can see. Okay. Okay, so now we have what is the pOH of a solution in which 14.20 grams of phosphoric acid are dissolved in 1.50 liters of water. Okay, so the first step will be, we'll write a balanced ionization or dissociation equation or reaction. So in this case will be ionization because we are dealing with an acid. So we'll go H3PO4 in aqueous solution will be ionized into 3 hydrogen plus and PO4, and those are aqueous solution, okay? Aqueous solution 3 minus. Okay, so now we see that this is balanced, and we are, what is given here is 14.20 grams of this acid here. And what we are looking for is the concentration of hydronium. Why hydronium? because hydronium and hydrogen are the same. So we'll calculate the concentration of hydrogen, and then we say that, okay, this is the concentration of hydronium. They are the same thing. Okay, now let's using the stoic or molar mass and all the things that we need to know. Now, keep in mind, concentration is, the units are moles per liters. So we'll start with what is given, 14.20 grams, and I will write it, of H3PO4 times, in order to find the mole, so what do we have to do here? We have to use molar mass. So from grams to moles, we move with using molar mass. Now on the side, I will see and calculate and show you what is the, how do we use it. Now, molar mass of hydrochloric acid, sorry, not hydrochloric acid, but potassium phosphorus acid is, we have 3 hydrogen, 1 potassium, and 4 oxygen. So the molar mass of phosphoric acid is 98.0 grams per mole. What does that mean is that what we have is, if we have 98.0 grams of H3PO4, then we have 1 mole of H3PO4. Or if we have 1 mole of H3PO4, then we will have 98.0 grams of H3PO4. So now what we have is 2 ratio. They are ratio of 1. So they are the same thing as saying 100 meters, 1 centimeters, or 1 meter. So now, in order to cancel the grams that we have here, we have to use a ratio that grams are at the opposite side. So we will use a ratio 2, in which 1 mole of H3PO4 is 98.0 grams of H3PO4. So now grams of H3PO4 and grams of H3PO4 are canceled out because they are in 2 opposite places. Okay, now we have moles of H3PO4, and we want to move now to moles of H plus. What do we do in this case is we use molar ratio. It's the same thing as we did when we were calculating the concentration of ions. So here, what we will do is we use molar ratio. So what do we have in terms of molar ratio is that 1 mole, how do we know? Because we have the coefficient of 1. 1 mole of H3PO4 is giving us 3 moles of H plus. Here we have 1 coefficient of 1 here and coefficient of 3 in front of H plus. Or when we have 3 moles of H plus, those are coming from 1 mole of H3PO4. Okay, so now we have 2 ratios, the ratio 1 and ratio 2. And those again are ratio of 1. Now, in order to cancel the moles of H3PO4, we have to use ratio 2. So ratio 2 will be 1 mole of H plus over, 3 moles of H plus, 3 moles of H plus over 1 mole of H3PO4. So moles of H3PO4 are canceled out because they are in two opposite places. One is in the top, the other one is in the bottom. Up to now, what do we have is number of moles of H3, H plus. However, we want the concentration, which is moles per liters. This amount of H3PO4 is dissolved in 1.50, this is what the question is saying, 1.50 liters of water. So then we go, okay, this is in 1.50 liters of water. So now at this stage here, what do we have is moles per liter, which is the concentration. Now in your calculator, you will go 14.20 times 1 times 3, divide the whole thing, open brackets, 98.0 times 1.50, close brackets, and then you will have a concentration of 0.289795 and so on. And this is the concentration of hydrogen ion, which is the same as saying the concentration of hydronium. And it is moles per liters. Okay, now that we have the concentration, using the flow chart, we are looking for the pOH, okay? But we have the concentration of hydronium. So now we will find pH first, going as negative log of the concentration of hydronium. So negative log concentration of hydronium will be 0.5379 and so on. And then in order to find the pOH, we will use 14 minus pH. So 14 minus 0.5379 and so on. So 14 minus the answer will be 13.46. So now you may say, why is it recorded into 2 digits after the decimal point? Because pH and pOH have the power of significant digits is into the digits after the decimal point. And now we have the lowest one is 3, and this will be 13.62, 462 as the final answer, not just 46. Because we have to have 3 digits after the decimal point. I hope that this makes sense. Let's move now to the next. So let's start by writing a dissociation equation. It will help if we have a pen. OH in aqueous solution will be aluminum in aqueous solution 3 plus 3 hydroxide in aqueous solution. What is given here is that the pOH is 9.89, and since we are here, let's find the molar mass of aluminum hydroxide, which is 1 aluminum, 3 oxygen, and 3 hydrogen is 78.01 grams per mole. Okay, so now the fact that we have pOH, the concentration of OH will be in aqueous solution, of course, will be 10 to the power of negative pOH. So will be 10 to the power of negative 9.89. And this will be equals to 1.28824,955. So times 10 to the power of negative 10. And this is moles of hydroxide per 1 liter. This is where we will start. Okay, so now we have moles of hydroxide, 1.288 and so on times 10 to the power of negative 10 moles. So I will write all the units so that you can see over liter times is dissolved into 350 milliliters or 0.350 liters. So 0.350 liters. So liters and liters are canceled out. What do we have now here is moles of hydroxide. Now we won't move to moles of aluminum hydroxide. So that means that we will use the molar ratio. We'll move here. Okay, so now we have the molar ratio. So this will be 3 moles of hydroxide are as a result of 1 mole of aluminum hydroxide, which means that moles of hydroxide and moles of hydroxide is cancelled out. Up to this point, what do we have is moles of aluminum hydroxide. Okay. Now we want the grams of aluminum hydroxide. So then we will use the molar mass. So in 1 mole of aluminum hydroxide, we have 78.01 grams of aluminum hydroxide. So then what does that mean is we'll use the ratio moles of aluminum hydroxide as 78.01 grams of aluminum hydroxide. So moles of aluminum hydroxide is cancelled out. And now what do we have up to this point is grams of aluminum hydroxide. And this is what we want. How many grams of aluminum hydroxide are there? And when you enter it in your calculator, you will see. So first what you will enter is the concentration times 0.350 times 78.01 grams over 3. Because they are 1, so 3. So you will have what the calculator is giving you 1.17245 and so times 10 to the power of negative 9 grams of aluminum hydroxide. Now, let's go back to the question and see what do we have. For the pH is 2 significant digits and for volume is 3 significant digits. So we will record it into 2 significant digits. So the final answer will be 1.2 times 10 to the power of negative 9 grams of aluminum hydroxide. We'll record it into 2 significant digits. This will be the final answer. Okay, let's move now to the other example. So in this example, what we have is how many grams of magnesium hydroxide are dissolved in 400 milliliters of water if the pH is 12.32. Okay, so now let's write a dissociation. Why is this a dissociation? Because it is a base. Okay, so now we'll have magnesium hydroxide in aqueous solution will be dissociated into magnesium 2 plus 2 hydroxide in aqueous solution. Okay. Now what we have as given is that the pH is 12.32. Since we are dealing with a base, we have to find pOH, which is 14 minus pH equals to 14 minus 12.32. And this will be 1.68. So pOH will be 1.68. The concentration of OH based on the flow chart will be 10 to the power of pOH. So negative pOH, 10 to the power of negative 1.68. And the concentration of the pOH will be 0.0208 and so on moles of OH per liter. This is what we have for the concentration of hydroxide. Okay. Now, after we write the balanced dissociation or ionization reaction, then we will move to the finding the mass of magnesium hydroxide. So what do we have is the concentration of hydroxide. So concentration of hydroxide is 0.0208 moles of hydroxide per liter. This is dissolved into 400 milliliters or 0.400 liters. So liters and liters are canceled out. What do we have up to here? Is moles of hydroxide. We don't want this. We want the moles of magnesium hydroxide. So we will use the molar ratio 1 to 2. How do we know this? Because we have this 1 here to 2. Okay, so 1 mole of magnesium hydroxide is giving us 2 moles of hydroxide, which means that we'll write 2 moles of hydroxide and 1 mole of magnesium hydroxide. So moles of hydroxide and moles of hydroxide are canceled out. That up to here gives us what is the moles of magnesium hydroxide. Okay, we don't need this. We need the grams of magnesium hydroxide, which means that we will use the molar mass. So 1 mole of magnesium hydroxide is 54.33 grams of magnesium hydroxide. So moles of magnesium hydroxide and moles of magnesium hydroxide is canceled out. And what we have up to here is grams of magnesium hydroxide. And this is what we want. So now in your calculator, you will go whatever is the concentration times 0.400 times 1, which you don't have to put it, times 54.33, divide the whole thing by 2, and you should have an answer of 0.208 226, and y is 226. Oh, this is and something else. The calculator is giving grams of magnesium hydroxide. But to consider the correct significant digits, we will say that we'll record it into 2 sigdigs. So the final answer will be 0.23 grams of magnesium hydroxide. Why is number of significant digit 2? Because we count the numbers of pH, whatever is the number of digits after the decimal point, and being 12.32, you have two significant figures here. So the final answer will be on 2 significant digits. Okay, so now let's move to next example. What is the pOH of the solution with 6.1 grams of sulfuric acid dissolved in 300 milliliters of water? So we'll start with the ionization equation. So H2SO4 in aqueous solution will be ionized into 2 hydrogen plus in aqueous solution plus SO4 2 minus in aqueous solution. Good. This is balanced equation. What we have is 6.1 grams of sulfuric acid. Okay, and we are looking for pOH. Okay. Now, the concentration, let's find the concentration of hydrogen, because the concentration of hydrogen is the same as the concentration of hydronium. And then from there, we'll find the pH, and from there, we will find the pOH. Okay, good. So now, let's figure out what is the molar mass of the sulfuric acid by calculating that we have here 2 hydrogen, so 2 times 1.01 plus 1 sulfur, which is 32.07, plus 4 times the mass of the oxygen is 60. So molar mass is 98.09 grams per mole. Okay, now that we have all the information that we need, then we can start finding the molar mass, the number of moles. So 6.1, always start with what is given, grams of sulfuric acid, H2SO4, times, using the molar mass, we'll go 98.09 grams of sulfuric acid is 1 mole of sulfuric acid. What do you have up to here? Is moles of sulfuric acid. We don't want moles of sulfuric acid, we want moles of hydrogen or hydronium. So therefore, we will use the molar ratio. So what do we have in the equation is 1 to 2 as the molar ratio. So 1 mole of sulfuric acid gives us 2 moles of hydrogen. 1 mole of sulfuric acid gives us 2 moles of H+. So grams here are canceled out, moles here are canceled out. Now what do you have up to here is moles of hydronium or hydrogen. We don't want this, we want it to see the concentration. So this is dissolved in 300 milliliters of water. So 0.300 liters will give us, this one up to here, will give us the concentration of hydronium. Okay, good. Now that we have the concentration of hydronium, we can find the pH, sorry. So I know we have 6.1 times 1, which you don't have to put it in, times 2 times 1, divide by 98.09 times 0.300 after you open the brackets, and you will have 0.41455 moles of hydrogen per liter. Good. Now that we have this number, we can say that pH is negative log of the concentration of hydrogen. So this will be negative log of 0.4145 and so on. So a negative log of the answer will be 0.38238 and so on. Based on the flow chart, pOH, which we are looking for, will be 14 minus pH equals to 14 minus 0.382 whatever. So 14 minus the answer is equal to 13.61761 and so on. The sig digs are 2, so we will record it with 2 digits after the decimal point, so will be 13.62, and this will be the final answer. I think that those are all the examples that we have in terms of the word problems. Let me double check. Yeah, and now you can work on the assignment of lesson 3, and this concludes the videos for lesson 3. If you have take notes, if you have any question, ask me on tutorial or in class.